Okay, so this is lesson 4 on acid and base strength. Okay, so all acids and bases are not created equal. You could have concentrated or dilute solutions. So dilute solutions have a low molarity and concentrated solutions have a high molarity. So you'd have very few ions that were dissociated, or very few ions or molecules in dilute solutions. In concentrated, you would have to have a lot of ions or molecules. Okay, the strength is determined by how well the compound dissociates. So strength describes the tendency of the ionic compound to dissociate. So strong acids and bases completely dissociate. It says almost, but let's just say completely dissociate. Okay? Weak acids and bases only partially dissociate. Okay, so dissociate literally means to break into ions. Okay, your common strong acids are down here at the bottom of the page. Okay, so those are your common strong acids. So strong acids completely dissociate in water, and so the hydronium ion concentration is equal to the acid concentration itself at the beginning, before it dissociates. All other acids that are not on this list are considered weak. Okay, there's a couple more that would be considered strong acids. Basically any acid that has 2 or more oxygens than the number of hydrogens is considered a strong acid. Okay, so you basically need to memorize these common strong acids, because if it's not a strong acid, it's a weak acid. And so you are gonna have to memorize these guys. These are the 6 common ones that we use most often. But there are others, because think of chloric acid is HClO3. Well, that has 2 more oxygens than hydrogen. These are the only binary acids, but these are not necessarily the only ternary acids that are strong acids. Okay, so anything else is considered weak. All right, so here are some common weak acids. So some common weak acids are acetic acid, carbonic, phosphoric, hydrofluoric. Hydrofluoric is what we use in semiconductor technology. It eats glass. It's one of the only things that will eat glass. So we use it for that. Phosphoric acid is in your Coke. If it were a strong acid, it would hurt you very bad. So if you wanted to drink a soda, it's going to have some of that in it, probably. So good thing it's not strong. Acetic acid is basically vinegar. Carbonic acid is a blood buffer. It keeps your blood at a certain pH so that it doesn't deviate from that. So if it were strong, it would literally eat your veins. But it's not. It's weak. So so you don't necessarily need to memorize these. I would probably remember this one pretty well, because we like to use this one in a lot of assessment practices. We like acetic acid a lot. So I would definitely remember that one. But anyway, so weak acids dissolve completely in water, but they do not dissociate completely in water. So weak acids do not dissociate completely in water. Okay? So that means the hydronium ion concentration is much less than the concentration of the acid originally in the solution. And we're not worried about how to calculate these things for right now. Don't worry about dissociation constants and equilibrium expressions. I know that's in the teacher notes, but you're not responsible for that for this unit, so don't worry about that. Okay, so it says bases are similar. Okay, the only commonly used strong bases are compounds of hydroxide. Okay, well, it gets even more complicated. The only common strong bases are group 1 and 2 metal hydroxides. Those are the only common strong bases. So anything that's not a group 1 or 2 hydroxide is not a strong base. Okay? So now some of these things don't necessarily dissolve in water. Some of them are insoluble because hydroxides just by design like to be insoluble. If it dissolves at all of it that goes into solution completely dissociates. So it's considered a strong base even if it doesn't completely dissolve. There is a very common weak base. So the most commonly used weak base is ammonia. Ammonia is NH3. And we're not going to worry about equilibrium expressions for right now. But the most commonly used weak base is NH3. The most commonly used weak acid is acetic acid, which is why I would say these are two things that you probably really need to memorize. So, which metallic hydroxides are considered strong bases? Only the ones of group 1 and 2 metals. So, like if you had aluminum hydroxide, well, aluminum is not a group 1 or 2 metal, so it's not a strong base. If you had cesium hydroxide, cesium is a group 1 metal, so cesium hydroxide is a very strong base. Okay? Okay, and how do you know if it's a weak or strong acid in like a picture form? So if you look at this picture to the left, the strong acid, it's dissociated completely into hydrogens, which are the little white ones, and negative ions. So it's coming out as acid molecules, and when it hits the water, it dissociates completely, so there are no more acid molecules. With the weak acid, it's coming out as acid molecules, and it hits the water, and a few of them will dissociate, but most of them stay together as an acid. Okay? So that would be what a weak acid would look like in solution. And that's the end of lesson 4.